Hello and welcome to Mr. Wiley Teaches Math. Today we're going to talk about triangles and angles. First thing we need to know is that every triangle contains exactly 180 degrees. So if it has three sides that are connected, it has 180 degrees contained within. In this case, we've got a triangle that's already been drawn. It's a scalene triangle, meaning none of the sides are the same length. If we know that it has 180 degrees in total, we should be able to find the missing angle quite easily. If we started with the two angles we know, 35 and 65, and add them together, we get 100 degrees. We know that the entire inside is 180 degrees. If we subtract what we've already used on two corners, 35 and 65, and 100 in total, that leaves it with 80 degrees. So our missing angle must be 80 degrees. This works for any triangle. It works for a right triangle as well. So we have the corner down here marked with the little square, meaning that it's 90 degrees. We don't normally write the 90 on, but I will today. And again, we know that we've used 90 up in the one corner and 33 on the other. If I add those up, I get 123 degrees that have been used already, and whatever's left over from my 180 is my remaining angle. Looks like 57 degrees is the missing angle. Alright, so that was for a right triangle with a right corner. Works for equilateral triangles as well. The thing with equilateral triangles is that all the sides are the same length and all the angles are equal. They're all equal to each other. So in this case, we don't have to calculate this once. If it's an equilateral triangle, we have three angles, and we're going to divide it 180 into 3, which goes in 60 times, meaning each of the angles is 60 degrees. An isosceles triangle has two sides that are the same length and one that's a different length. The thing with an isosceles triangle, we have one angle that's the same, and then we have two that are going to be different. And they're actually equal to each other. They're different from this one, but they're equal to each other. So we had 180 degrees in total for all three angles, and we take away the 38 that we've already used. We're left with 142 degrees for the two angles. Because it's for two angles, we're going to divide it in half. How many times does 2 go into 142? Goes in 71 times. So we're left with 71 degrees over here and another 71 degrees over here. They're going to be equal to each other. Interesting thing that if you have a circle, the distance from the center or the origin to any outside point should be the same distance no matter where you draw it. So the edge of the circle to the center of the origin, mark that with an O, meaning if anywhere I draw that, now if I connect these, the last two sides, I've got an isosceles triangle. The last type of triangle is an obtuse angle, which means it has one side, one angle, greater than 90 degrees. So an obtuse angle, we've used that up at 120. We have an acute angle at 28. We're wondering what's left. So again, I'm going to take my 120 degrees and add the 28 to it. End up with 148. And I know that I have 180 degrees in total for my circle. So I'm going to take away the 148 that I've already used. I'm left with 32 degrees. So my missing angle is 32 degrees. Thanks for watching. Be sure to check the class website for additional examples and the assignment.